Now this is our seminar on differential equations. And so we are trying to solve first order differential equation y prime equals f capital of xy given on an interval, some interval, or maybe given on a natural domain. Sometimes we're discussing a natural domain. So it is when the domain is not given exactly, right, but it is a natural domain. And our goal is to find a function, explicit function, right? Y is a function of x when x belongs to, so is in this interval, where I is an open interval from A to B. Or sometimes it is difficult or impossible to find this explicit solution. Then we may ask to we may find an implicit solution of this differential equation. Implicit solution, like in task number 3 from our quiz. 3, or I think 3. It was 3. Okay, so how to do this? Okay, maybe we will so repeat some parts from the preceding seminar. So I have prepared some maybe not difficult problems. How to first how to create a differential equation from a 1 parameter or 2 parameter solutions, right? For example, so task number 1. Find a differential equation whose solution is the given n-parameter family. So we are given an n-parameter family of solutions, and we should find a differential equation. Okay. So 1a is the following: x squared minus cy plus c squared equals 0. So suppose this is a solution. This is a 1 parameter family of solution. How to find a differential equation? So our goal is using derivatives. So here we should use just the first derivative, because we have one constant c, so it must be a first order differential equation, right? How to use the differential equation, this implicit function and the derivatives of this function to create the differential equation. So let's differentiate this. Right? Let's differentiate. It will be 2x minus cy prime equals 0. Right. And so now we have an equation for c. So from these two, our goal is to solve maybe one of the equations for c and substitute in the other. So to eliminate c. Now our goal is to eliminate c. Okay. So I can do the following. So solve for c and get the following: 2x over y prime. But sometimes it is not correct, because we divide by y prime. It's not good to divide, right? Because we can lose some solutions, right? So it is preferable to multiply. So right, solve for c and then substitute into the original equation. But it is more preferable to multiply the original equation by y prime squared, I think, right? So let's do the following. Instead of this, we will multiply the original equation by y prime squared. And we will get the following: x squared y prime squared minus c y prime times y prime squared y plus c squared y prime squared equals 0. Then I know that cy prime equals 2x. And then substitute 2x for cy prime. So we'll leave the first term as before. Then c times y prime squared will be, so minus, it will be 2x times y prime times y. Right? And plus 2x squared. So we are done. This is a first order differential equation with no constants, so just what we need. Okay, so this is the first problem. Using the one parameter family to create the differential equation. Or we may ask ourselves the other problem, the other question. So given a differential equation and given a function, one parameter family, how to check whether this is a solution or not? So just differentiate and try to substitute in, to plug in, and if the substitution of this function, so the derivatives and this function into our equation will reduce this equation to identity in x, then it is a solution. Right? To create a differential equation and to check whether the given function is a solution. So maybe the example, let's consider an example. On the lecture, we have considered, so we were considering the following differential equation, and I told you that I know how to solve it, right? So I know that the solution is c e to x minus 1. Let's try to check whether this is a solution or not. To check, we need to find the derivative. It will be c e to x minus 1. And then substitute the derivative and the original function into our equation and check that this equation will turn to identity. Let's substitute y prime. So this expression for y prime, it will be c e to x minus 1. We should check that it is equal to x plus c to x minus 1. Is it true or not? Is this an identity or not? Identity, of course, right? We can cancel out x, and this is an identity. So this is indeed a solution, actually a solution. Right? Well, next, let's try to work with two parameter family. So maybe it's interesting. It will be interesting. Just a moment. Okay, task number 2. Given a two parameter family, y equals c1 cos 3x plus c2 sine 3x, find the corresponding differential equation. So we have a two parameter family. What is the order of the differential equation? What will be the order of a differential equation? Correct, 2. Right. So we should create a the second order differential equation, right? Let's differentiate this. Y prime will be, so the derivative of cos is minus sine, so minus 3c1 sine 3x plus 3c2 cos 3x. Right. Next, y2 primes. This will be so. So we need to know y2 primes, of course. It will be minus 9c1 cos 3x minus 9c2 sine 3x. Okay, now what shall we do next? Do you know? Eliminate. Our goal is to eliminate c1 and c2. We can compare these three functions. And what shall we do to eliminate c1 and c2? Maybe add, but if we add them, that will the constants be eliminated or not? No.
We can factor out -9, and that will leave us with the first equation.
Right. If we multiply, right, or maybe divide by 9, or maybe we may multiply the first equation by 9. Let's multiply it by 9 and add to the last equation, to the last function, right? And this will give us 9y plus y2 primes is equal to 0. So this is the answer. So this is a two-parameter family of this equation. Okay. So I think it is done. So now we will go to continue to study the methods of solution of differential equations. And now we will deal with separable differential equations and homogeneous differential equations. But we will consider more complicated differential equations which can be reduced to separable or homogeneous differential equations by some substitution, right? Or replacement, maybe, in other words. Let's consider, for example, it will be equation task number 3. Let's try to solve the following differential equation: y times x plus xy dx equals x times 1 minus xy. So, xy dy. Okay. So this equation is not a separable differential equation. Because, so how to check whether the equation is separable or not? Do you know? Should I recall how to check separable differential equation? Follow. Do you know what is separable differential equation?
Put all the x terms on one side and on the other.
Right. Now, this is the method of solving, but how to see how to decide whether this equation is separable or not? So a separable differential equation can be represented as the product of two functions. So, right. So this is a general form of a differential equation, right? But if this function can be represented as the product of two functions, f of x times g of x and g of y. So the first function depends only on the first variable and g of y depends only on y. So if f of x, y can be represented in this form, then it is a separable. And then the method is to move, so the method of solution is to rewrite y prime as the ratio of differentials and move dx to the right hand side and g of y to the left hand side, right? And then integrate, right? So this equation is not a separable differential equation, but it can be reduced to the separable differential equation by some replacement, by some substitution. Let us consider the following function: t, let it be equal to the product xy. if t is equal to xy. Okay, then let's try to make a substitution. Okay, then we need to know dt. Dt is equal to x dy plus y dx. Okay, and so okay, we have maybe x dy. Let's try to replace it so we can see. Let's make this substitution. So first replace y by t over x. So y is equal to t over x. Maybe okay, so maybe it's better to multiply. I think it's better to multiply by x, right? I don't want to divide. Let's multiply this by x. And we will come to the following: xy times 1 plus xy dx equals x squared 1 minus xy dy. Now let's make a substitution. Xy is replaced by t. Then x dy can be represented as dt minus y dx. So it will be x times 1 minus t, and then x dy is replaced by dt minus y dx. And our last step will be to eliminate y, right? So we have this equation, but we have y and we want to eliminate y. And then let's expand this part. We will get the following: t dx plus t squared dx equals, now it will be x dt. So minus xy dx minus xt dt plus xy t dx. So just expand. And after this we can replace xy by t. It is t, and this is also t. Let's do this. And we will have the following: t dx plus t squared dx equals x dt minus t dx minus xt dt plus t squared dx. Well, okay, now look at this equation. We can cancel out similar terms, right? And let's just move all the terms to the left hand side, and we will get the following: 2t dx, right? So this and this will give us 2t dx, then minus x dt and plus xt dt equals 0. Or maybe I think it's better not to do this. Just a moment. It's better to so to leave these two terms on the right. So because I want to divide them, so I will do the following. I will represent it as so let it be x dt minus xt dt. Then it is equal to x times 1 minus t dt. Okay. Now, is this equation separable or not? How to check this? Separable or not? So the product of, so each factor, we have no factors depending on the involving, so no factors involving the sum or difference or some linear combination of different variables, right? Look at this. Only t multiplied by dx, then x is multiplied by 1 minus t. So each factor depends on only one variable, right? So this shows that our equation is separable. Now we want to solve this equation. To solve this equation, we should collect the terms, so the terms with x on the left-hand side and move t to the right-hand side, right? So we have dx, then we should divide by x, right? Okay, Omer and Pahanat, is it clear? So we should move x to dx, so we'll look at this. So we have differentials, dx and dt. These differentials show that we should collect all the factors with x on the left-hand side. So we should move x to this part, to the left-hand side, and move t to the right. So we should divide by x and divide by t. So if we divide both parts by x, we will get dx, so 2dx over x, equals, and then divide by t, 1 minus t over t dt. So we have separated variables, and now our goal is to integrate. Let's integrate. Okay, so the integral here is, so let's start with this integral. So the integral of 1 minus t over t dt. Okay, how to find the integral? Okay, Hanat and Omar, do you know how to integrate? Right? So what shall we do now? You don't know, right? 1 over t minus 1 dt. But it is very difficult to solve differential equations without integration.
But today, like, I can bring the table of integration.
Right, table of integration. Yeah, you have formulas, but you should know the methods of. So not all the integrals can be taken from this table of integration, right? You should know the rules of integration, and you should be able to make substitution for integration. So there are several methods how to integrate. Not all the integrals are like in the table of integration. Okay. Okay, so first separate, so split into two fractions. Then what is the integral of 1 over t? This is the integral from the table. So it is the difference of two integrals. What is the first integral? What is the first integral equal to? The logarithmic function, the logarithm. t minus t. So the integral dt is t. Okay, plus the constant, plus c, right? Correct. But in differential equations, we need to add c only to the part with x, so we can skip this. So, but I will write plus c, right. And the next integral. 2dx over x is 2 ln absolute value of x. And so we can write the, next we should equate this integral plus c, this integral, and this integral. And this answer, ln t, the absolute value of t minus t, equals, we should write c only on one side, right? So it will be 2 ln absolute value of x plus c. Okay, we can simplify this. We can move 2 to the power of x using the properties of logarithm. So it is the same as minus t equals ln x squared plus c. Okay, next let's make back substitution. So we should substitute xy for t, right? It will be ln xy minus xy equals ln xy squared plus c, or it can be rewritten if we gather these two logarithms together. We will get the following. So it will be ln xy minus ln x squared y squared equals xy plus c, and the difference of logarithms will be the logarithm of the ratio. So it will be xy divided by xy plus c, the logarithm of 1 over xy equals xy plus c.
On the right hand side, how does x squared change to xy squared?
Just a moment. So on the right hand side of this?
Yes. So you change it from x squared to xy squared.
Okay, so it is not correct. Thank you. I have mistaken. I didn't notice this. Right. And so we should subtract x squared, just x squared, and this will be, I'll correct this, ln y, so y over x equals xy plus c. Okay, now let's try to discuss, what about the lost solutions? Are there any lost solutions, right? If y is a function of x, then so y equals 0 is a solution. So we have divided, right? Let's look at this, of these two equations, this one and this one, right? We have divided by x and have divided by t. Okay, so we can lose the solutions, particular solutions. X equals 0 or y equals 0. If y is a function, so if we consider y as a function of x, then x cannot be equal to 0, so this is not a solution, but y, so, or sometimes if our equation is written in this form, then x equals 0 is also a solution. So what about y equals 0? Is it a solution or not? Y equals 0. Will it satisfy the original differential equation? If y equals 0, then if we substitute 0 on the left hand side, we will get 0 equals, and then what about dy? Dy is also 0. Right. So y equals 0 is a particular solution, and we should include this solution in the answer, right? And x equals 0 is also a particular solution, right? So this is an answer.
But you said we can't divide by x.
Okay, we have divided by x and divided by t. So we should check after this. We should check if we lose or not lose the solutions, right? Have we lost the solutions or not?
So the first thing to check if we can divide by x, then substitute 0 in the original equation and see if we get
right. And x equals 0 and dx equals 0 is the same. So if the differential equation is written in this form, then both y equals 0 and x equals 0 satisfy this equation, and so we should add them into the final answer. So we may divide if we need. If we want to separate variables, we need to divide, but as a result we may lose equations, lose solutions, right? Right. And now we will consider other substitutions that will reduce our equations to separable or homogeneous. Now let's consider the next example. I will clean this part of the blackboard. Right. So task number 4, find a general solution of the following differential equation. X plus y plus 1 dx plus 4x plus 4y plus 10 dx equals 0. Now we consider this differential equation, and we can see that this differential equation is also is not separable and not homogeneous. Okay, and so the first method. So you can see. So you should check. Let it be the method. So if we have something like a1x plus b1y plus c1 dx plus a2x plus b2y plus c2, so not dx but dy, equals 0. If you have something like this, you should look at this linear combinations of x and y. Or maybe you should consider these two linear expressions, right? And if we equate them to 0, right? If we consider these straight lines given by this equation, right? Then if they are parallel, so if these coefficients, the coefficients a1, b1 and a2, b2 are proportional, then we should make a substitution. U equals x plus y. So not x plus y, but a1x plus b1y. And if they are not proportional, if this parts are not proportional, then we should proceed in the other way. So it will be discussed later, but now we will consider okay, we will consider the situation when these parts are proportional. Your question.
So you said you're not homogeneous and check by substitution x and y is x.
Right. Okay, how to check it in this situation, right? Let's check homogeneity by substituting tx for x and ty for y. A homogeneous, let's speak about homogeneous equation. It is of the form f of x t, f of x y, and our function for homogeneity, we need that f of tx and ty be equal to f of xy. Then the equation is homogeneous, or if a differential equation is given in the form p of xy dx equals q of xy dy, like ours, like in our case, then we should check whether these two functions are homogeneous of the same degree. So we should substitute tx and ty for x and y, and these two functions should be homogeneous of the same degree. But, so look at this function, x plus y plus 1. Is it a homogeneous or not? If we substitute t, so if we consider tx plus ty plus 1, it is not a homogeneous because of 1. Okay, so maybe it's a problem. So should I recall the definition of a homogeneous function? No? So a homogeneous, so means that p of, but I'd like to repeat, ty should be equal to t raised to some power m, maybe, times p of xy. So this function is homogeneous, but you can see that this function is not homogeneous. Right?
But if one was equal to t,
right, but without 1, it will be homogeneous, of course. Right? If there are no 1s, right? If we remove 1 and if we remove 10, then it will be homogeneous. Right. But now, if it is not homogeneous, then the method is to make a substitution, u equals x plus y. So a1 x plus b1 y, and in our case it will be x plus y. So let's do this. Okay, u will be equal to x plus y. Okay, then du equals dx plus dy. Then let's substitute this into our original equation. And this will give us u plus 1 dx plus 4u plus 10 times, and we will substitute du minus dx for dy, right? Du minus dx equals 0. Okay, and this must be a separable differential equation. A separable differential equation. Let's check this. So it will be u dx plus dx plus 4u du minus 4u dx plus 10 du minus 10 dx equals 0. Then we will collect terms with dx and collect terms with du. So collecting terms with dx will give us So we have minus 3u minus 9 dx equals, and then collect terms with du on the right. It will be minus 4u minus 10, so plus 10 then du. Then let's multiply both sides by -1. 3u plus 9 dx equals 4u plus 10 du. And then we can see that the variables are separated, right? So we can see that dx equals 4u plus 10 over 3u plus 9 du, if I'm not mistaken. So I hope that it is correct. Now let's integrate both parts. And after all, we will consider particular solutions. So u equals -3 may be a particular solution, right? So u equals a -3. We should check whether it is a particular solution or not. Right. Let's integrate. How to compute the integral 4u plus 10 over 3u plus 9 du. So first of all, I will do the following. I will move the constant out of the integral, u plus 3, and here we have 2u plus 5 du. What shall we do next? Okay, I think Santiago, do you know how to integrate? So, so we need to integrate this function. How to find this integral? Right, denominator in two parts. Which parts? 2u and then no, plus 5. So plus 5 is the original, so we should divide denominator into two parts. Plus 5 plus 5 doesn't work. Okay, we can divide, just divide. But so polynomial long division, but I prefer Russian division. Right? U plus 3. So just divide maybe. 2u plus 6, and so subtracted will be -1, right? And so this means that our fraction is represented as 2 minus 1 over u plus 3 du. Is it clear? So, or partial fraction decomposition maybe. So this is the first part. So in the partial fraction decomposition, we need first to compare the degrees of the numerator and denominator, right? And if the degrees are equal, if the fraction is improper, if the degree of the denominator is greater than or equal to the degree of the numerator. So just a moment, this is numerator and this is denominator, so I have confused, sorry. Okay, so if the degree of the numerator is greater than or equal to the degree of the denominator, we should divide and find the polynomial, the integer part, right? Okay, so next continue. 2/3 times 2u minus, okay, Omar, do you know the answer? The integral of 1 over u plus 3 Santiago, do you know how to integrate? 1 over u plus 3. What is the answer? Okay, how to integrate this? So du over u. What is the integral? Table integral? No, it's not u to the square. So do not confuse this. So if we have u raised to some power alpha, maybe du, the answer is u to the power alpha plus 1 over alpha plus 1. But this, so almost, right, but it doesn't work for alpha which is equal to -1, right, in our case. But in our case, the answer is different. The logarithm of u, the absolute value of u, right, plus c. Right, and if we integrate du divided by u plus 3, the answer is ln u plus 3. So we may, you may make a linear substitution if you need, but maybe you can remember this rule. So the rule is the following. If we know that the integral of f of x dx is equal to f capital of x plus c. Suppose you know this from the table maybe, right? Then we can easily integrate the function f of ax plus b. What is the answer? Almost the same. So we should just multiply by the constant, so it will be f of ax plus b plus c. So if we know this integral, we can easily integrate this, right? Just a is equal to 1 in our case, and b is 3, right? Okay, so the logarithm of u plus 3. Okay, plus c. And let's go to our integration. It is x equals 2/3 of 2u minus ln u plus 3 plus c. So plus c should be added here, x plus c. Next, we should go back to to our original variables x and y, and this will be let's multiply by 3 first. It will be 3x, but we needn't multiply 3 by c by 3 because c is an arbitrary constant, so we will leave it as c. Next, 4u minus 2 ln u plus 3. And next, go back to our original variables x plus y. Minus 2 ln x plus y plus 3. Okay, and so we can collect 3x and 4x, right? And we can represent the answer in the form x plus 4y minus 2 ln x plus y plus 3 equals c. Okay, so I want to check the answer. Okay, well, and now let's try to check whether u equals -3 is a solution or not. Is it a solution or not? So let's check u equals -3. We have divided by 3u plus 9. What about u equals -3? So then we have then we have, so if u is equal to -3, then our differential equation will be, so x, this corresponds to the solution x plus y equals -3, Then we have the following. So let's substitute this into our original equation. We will get minus 3 plus 1 dx equals minus 12 plus 10 dy. Is it identity or not? How to check? Let's compute. Minus 2 dx equals so minus 2 dy. So it seems to me that it is plus. Sorry, it was plus and equals 0. So is it correct? Is it identity or not? Dx plus dy equals 0. But if we have this, then it follows that dx plus dy equals 0, of course. So this is the same. So this is a solution. Okay. So x plus y equals negative 3 is then the solution. Okay, the next task. It's number 4, I think. Let's try to solve the following. Y prime equals x minus y plus 3 divided by x minus y. Okay, what shall we do? So is it a separable differential equation or homogeneous? Not, of course. Then we can see that we have the ratio of linear functions, right? Linear into variables x and y. And these parts are proportional, x minus 1 and x minus y. If not, we will apply another technique. But now the method is to make a change of variables, to introduce a new function u, which is equal to the difference. Let it be y minus x. So proportional to x minus y or y minus 6. So let it be this. And we will substitute this function into our equation. First, we should differentiate, so because we need to know to replace y prime, right? Let's differentiate, and it will be u prime equals y prime minus 1, because we differentiate with respect to x. X is our independent variable. Next, substitute, and so we have y prime equals u prime plus 1. Substitute this for y prime, and we will get a u prime plus 1 equals, then x minus y will be minus u plus 3 over minus u. And this can be simplified and written in the form. So I don't want to simplify. Now I claim that it is the separable differential equation. Separable differential equation. Because we can rewrite it in the form du over dx equals u minus 3 over u minus 1 du over dx equals, so just subtract, it will be minus 3 over u. Then we can rewrite, we should move u to the left and dx to the right, and we will get the following. So I will use this space, u du equals minus 3 dx. Then integrate both parts, and we will get u squared half equals minus 3x plus c, or u squared equals minus 6x plus c. Okay, then we will make back substitution. Let's substitute y minus x for u, and we will get y minus x squared equals minus 6x plus c. Or we can rewrite this in the form, so y squared minus 2xy plus x squared plus 6x equals c. Are there any lost solutions? No, because we did not divide, and so we can't divide by 0, so x equals y is not the lost solution, right? So this is the answer. It is not difficult. And now we will proceed to the solution of the equation, so of a similar type, but we will consider the case when the linear parts of numerator and denominator are not proportional. So now we will consider the equations of the form, so it will be y prime equals, generally it is f depending on a1x plus b1y plus c1 over a2x plus b2y plus c2, some function. Okay, so and if the linear parts, so a1, b1, are not proportional to a2, b2, so this means that if we consider two straight lines given by a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0, then these straight lines are not parallel, and they intersect each other at a singular point. So at a single point they have a point in common, right, this one. And then in this case the method is to make so to move the origin of the coordinate system to this point of intersection, and this operation will reduce our equation to a homogeneous equation. And now I will show how it works. Okay. So the method to move the origin intersection of lines L1 and L2. So this is L1 and this is L2. And this will reduce our equation to a homogeneous. Let's consider an example. Task number 5. Okay. We will try to solve the following. Y prime equals 2x plus 1 over 3y plus x plus 2. This equation of the given form. And step number 1, move the origin to the intersection of these two curves. So this can be represented as follows. Let's come to the new variables. Let's call them, let it be maybe C and T, maybe. Okay, so let x be equal to the new variable. Let it be x capital. It's better, I think. X capital plus some alpha, some parameter alpha, and we will find alpha in what follows. And y equals y capital plus beta. This is a change of variables which moves the origin to the point of intersection of two straight lines. Let's make a substitution. Then, what about dy over dx? The ratio of differentials, if we make this change of variables, what will happen with this? Dy over dx. What is your opinion? The ratio of differentials. So we need to substitute y prime. Or maybe we will get, so y prime is equal to y capital prime with respect to the variable x, okay, and okay, and the variable x capital also, right? Because so to differentiate with respect to x small is the same as to differentiate with respect to x capital. So this the ratio of differentials. So just differentials, right? If we make a shift, so they will not change, right? So it is equal to dy over dx capital, right? And let's substitute it here. So then we will have y prime equals what is 2x? It will be equal to 2x capital plus 2 alpha plus 1 over, so 3y will be equal to 3y capital plus 3 beta plus x plus alpha plus 2. Okay. And now we want this coefficient to be equal to 0, and also these coefficients, right? So we want two alpha plus 1 equals 0, and 3 beta plus alpha plus 2 also equals 0. So this is the same as to find the point of intersection of two straight lines. Look at these straight lines, right? Solving this is the same as to find the intersection of these two lines, right? Let's solve. So alpha is equal to -1/2. Then 3 beta will be equal to -2 plus 1/2. So 3 beta is equal to -3/2. So beta is equal to the same, -1/2. And so our change of variables will look like x small is equal to x capital -1/2, and y equals y capital -1/2. Then we will proceed to step number 2. Step number 2. After this substitution, we will get, so let's write this, let's substitute -1/2 for alpha and -1/2 for beta. Then this equation will be rewritten in the form y prime equals 2x capital over 3y plus x. So this is the original equation, the old equation. Then we are preparing for the substitution. Okay, so they are so the ratio of differentials is the same. So after this substitution, the ratio of differentials will be the same, right? Okay, and so we have substituted this, and we were looking for the parameters alpha and beta, so that so this constant term be equal to 0, right? And this this constant term also should be equal to 0. 3 beta plus alpha plus 2 should be equal to 0, right? I have solved this system of linear equations. And this is the resulting function and the resulting differential equation. And then we will make a we should consider this differential equation and decide and determine the type of this differential equation. What is the type of this differential equation? Is it separable or not? Not separable, right? It is homogeneous. And so we know that homogeneous differential equations should be solved by using the following substitution: y equals u times x, right? The question?
Can you just show how it's homogeneous again?
Homogeneous, right? So we should substitute tx for x. So we should find 2 times tx and 3 times ty plus tx. And t can be cancelled out. So it is equal to 2x plus 3y plus x. So this proves that our differential equation is homogeneous, right? But the original is not, right? Okay, so no, it is not related to a homogeneous system, of course. So a homogeneous function, if you substitute, so a function f of 2 variables x and y is called homogeneous if it is equal to f of tx, ty. So to check whether the function is homogeneous, we should substitute tx for x and ty for y and check this equality, right? So now this proves that our function is homogeneous and our differential equation is homogeneous. Okay, well, now on substituting this, we should find the derivative y prime will be equal to u prime times x plus u, because we differentiate with respect to x. Then substitute it here, and we will come to u prime x plus u equals 2x over 3ux plus x. Okay, then let's multiply by, so we may divide by x, of course. Let's do it. X can't be equal to 0 because we have the differential equation dy divided by dx, so dy over dx. So the derivative of y with respect to x can't be equal to identical 0, right? So let's divide by 0. We will get u prime x plus u equals 2 over 3u plus 1. And that we need to separate variables. Equals, first we should move u to the right. 2 over 3u plus 1 minus u. This is the same as u prime x equals, so it will be 2 minus 3u squared minus u over 3u plus 1, right? And then du over dx times x equals 2 minus 3u squared minus u. 3u plus 1. And then separate variables plus 1 du over 2 minus 3u squared minus u equals dx over x. Okay. And now, right, shall we? Okay, so now we will solve this. Well, and in just a moment, I thought that it is just a moment. I will have a look. I hope that I didn't make a mistake, but I will maybe check in just a moment. Maybe so. What's the problem?
Everything is
correct, right? It seems to me that it must be so the it's no mistake, right? Okay, so it's possible to solve, but it seems to me that it was more simple, but maybe not. So now, okay.
Is there another way to solve it?
No. So it's okay. So let's solve it. Right. Not another, but it seems to me that if it would be so if we had so 6u, it would be better to more convenient to solve. But maybe it's okay. I think right. Well. Now let's solve it. So let's try to solve this one. 3u plus 1 du over 2 minus 3u squared minus u. How to solve this differential equation? Okay.
We might be able to
right. So if we try to find the roots of this, let's try to find 3u squared plus u minus 2 can be factored, factorized as, so it has a root, one root is -1. Then it can be written as u plus 1 times 3u minus 2, 3u minus 2. Okay, so it's okay. Then let's factorize it. So then 3u plus 1 over u plus 1 times 3u minus 2 can be represented, so we can use partial decomposition, right? Partial fraction decomposition. Can you use it? So it is used for integrating rational functions like this. And Mahanat and Omar, do you know how to? What shall we do next? Sorry? Right, of course, yes. So partial fraction decomposition means that we should represent this fraction as the sum of two fractions with simpler denominator. So a is a constant. We will use the method of indeterminate coefficients. A over u plus 1 plus b over 3u minus 2. Then let's find a and b. What are A and B. So it is A times 3u minus 2 plus B times u plus 1 over u plus 1, 3u minus 2. And then we have the following: 3u plus 1 equals A 3u minus 2 plus B times u plus 1. And then let's find A and B. By substituting, we may use substitution. So let's substitute u equals minus 1, negative 1, and we will get minus 2 equals A times minus 5. So A is equal to 2/5. And after this, we will substitute 2/3 for u. And we will get 3 equals B times 2/3 plus 1 is 5. So times, sorry, 5/3. Okay, so am I right? 3, 2, right. So B is equal to 9/5. I hope that it is correct. Right, and then it is equal to 2/5 times the integral, so du over u plus 1 plus 9/5 du over 3u minus 2. It is equal to 2/5 ln absolute value of u plus 1 plus 9/5. So divide by 3 by the coefficient, so 15 ln 3u minus 2 plus the constant. So let's go to the original differential equation, this one. Let's continue to solve this. So we have found the integral of the left-hand side. Now, next, it is easy, very easy to integrate the right-hand side. It is the logarithm of x, of absolute value of x, and now let's substitute it into our equation. So I will remove this. We need not this part. Then I will move here. We have the following: 2/5 ln u plus 1, 3/5 ln 3u minus 2. Oh, sorry, and negative. So I have changed this sign, right? So it must be minus 2 and minus, right? So because I have changed the sign of the denominator, it should be minus. Minus and minus. And so I will improve this. Minus, minus equals what? Ln plus c. After this, we can collect these logarithms, right? Let's collect them. So we can represent this as multiply by 5 and okay, so rewrite this in the form if we multiply by 5 and move all these terms to the right, we will get the following: 5 ln x plus 2 ln u plus 1 plus 3 ln 3u minus 2 equals, so an arbitrary constant c. Then collect all the logarithms and we will get the following: ln x to 5, the absolute value of x to 5, plus, so times u plus 1 squared times 3u minus 2 cubed equals c. Then can we eliminate the logarithmic function? Do you know? Just, yeah, we can raise the exponent to this power. And then we will get the following: the absolute value of x to 5 times u plus 1 squared times 3u minus 2. So it is the absolute value cubed equals, let it be c1, where c1 is a positive constant. But now I want to eliminate the absolute values. In that case, I should rewrite this in the form x to 5, u plus 1 squared, 3u minus 2 cubed equals c, maybe c2, where c2 can have an arbitrary sign. Any real value. But what about 0? Is it possible to do it equal to, is it possible for C2 to be equal to 0? Okay, we will decide it later. Next, so let's make a back substitution. So let's substitute the ratio y over x for u. So it will be x to 5. Then y capital over x capital plus 1 squared, y capital over x capital minus 2 cubed equals C2. Right? Okay. Next, to avoid fractions, we can multiply it by x, and we will get x to 5y plus x squared 3y minus 2x cubed equals C2, multiplied by x. And then the last step is to come to the original variables. So because x capital and y capital can be found, so can be replaced by x plus 1/2 and y plus 1/2. Right, so this operation, right, to eliminate the absolute value. How to eliminate the absolute value? It comes from the logarithmic function, but now we have no logarithmic function, no logarithms. And so we needn't have the absolute values, because so it's difficult to operate with these solutions. So from the preceding equation we have e raised to some constant c. It is an arbitrary positive value. So right, it is c1. But if we have something, the absolute value of some function f of x or some function equals a positive constant. Is it possible to eliminate the absolute value? So positive constant. So if we write f of x equals an arbitrary constant, so it's the same, right? But we should consider the case when C2 is equal to 0, because we so is it possible for C2 to be equal to 0? Okay, right. So now we will finish. Let's complete this, and then that will be all, right? So this is our equation, and now let's make a back substitution. So it will be so we will substitute x plus 1/2. So x small plus 1/2 raised to the 5th power. Next, y plus x will be so it will be y plus x plus 1, right? Plus 1 squared, and then 3y minus 2x and plus 1/2 cubed equals c equals c2. Right, now let's check, is it possible for c2 to be equal to 0? So is it possible for x x plus y equals 0? So I think, so let's write, so I will think about this. So давайте я напишу так, so let it be not 0, so I will, we have no time now to check this, right? So I will have a look. Huh? But so it follows from here, C2, so from here, right? So C should be greater than 0, because E to C can't be equal to 0, right? So this is an additional value of C2, and we should consider this case when C2 is equal to 0. Is it, will it lead to a solution or not, right? So we should solve this problem. So bye, see you later.